Hello, in this video we are going to look at the equilibrium of a particle. So we have our particle here. I'm going to try to indicate it. So the particle is here, and we have a force P, a force Q, and a force 4N. So we need to know that when a particle is in equilibrium, there is no motion, so forces are balanced. Forces in one direction are equal to the sum of forces in the opposite direction. Now we always have to find the forces, the vertical force and the horizontal force, their sum in all directions. So what we are going to do, let us first look at this force here. It is Pn. We are going to handle force by force. Now we have this force Pn at an angle of 30 degrees. So this force here, you can see it move from here up to here. We know that force is a vector, so it will be moving from here, from the particle to this direction, taking an angle of 30 degrees. So we need to resolve this into horizontal and vertical component. So in resolving, that means we move from the point, we go to the right. When we go to the right, that is positive. So we are going to move to this direction, and then we move to the vertical. So when we are resolving the force, the side which is opposite is the sine. So this is going to be P sine theta, and that angle is 30 degrees, so it is P sine 30 degrees. Whereas the adjacent side of a force is of this force, if this is our angle, this side is adjacent, the other one is opposite. So this side is going to be P cos 30 degrees. So now we are going to see also this force here of the 4 Newton. So for the 4 Newton force, its angle to the horizontal is 45 degrees. So we are also going to resolve it into horizontal and vertical. Now I want you to know that whenever we are moving to the left, we shall take that to be a negative. So we move to the left. So this is going to be, the force is 4 newtons. So this is going to be 4 cos 45. Remember, it is moving to the left, so it is a negative force. We shall take it to be negative. Now when you move up, that is positive. And this is going to be 4 sine. Any side which is opposite, we shall take it to be sine. So this is going to be 4 sine 45 degrees. Alright, so now this other force is 2 newtons, and it is purely vertical. We don't have any horizontal component, and we don't need to resolve it. So this is our x-axis, and this is the y-axis. So we are going now to find the total sum of forces in the horizontal and in the vertical. So we shall find Fx, forces in the horizontal component. We have the P cos, let me write it here. We shall have forces in the horizontal as P cos 30 degrees. It is moving to the right, so it is taken to be positive. Now we have another force which is moving to the left. Remember, this 4 Newton is moving in this direction, so you have to take this route, then up. Negative, positive. When you move like this, negative, down, it will be negative. So down is negative, up I'm taking to be positive. Right, positive, left, negative. So here we are moving left, negative, then up. So the horizontal is negative 4 cos 45. So but remember, the sum, let me put the sum of horizontal forces will all be equal to 0 if whatever the body is in equilibrium. So in this case, the summation of all forces in the horizontal, I'll have to take the P cos plus this, but this is a negative, so we have a negative here. So we shall have to get in 0 because the particle is in equilibrium. It can't go to the right and can't go to the left. So when you sum up all the forces, we must get 0. Or forces to the right will be equal to the forces to the left. So in this case, we shall say that P cos 30 degrees is equal to 4 cos 45 degrees. So if we are interested in the P is going to be 4 cos 45 degrees over cos 30 degrees, and press the calculator. Our P is going to be 3.27 newtons. Alright, now what about the vertical components? Now vertical, we have this force sine 45 and have this P sine 30. Then we have this one moving down. So upward forces, so the summation of all forces in the vertical, that is along the y-axis, we have those which are going up, which are taken to be positive. The one which goes down, and it is the Q, will be negative. So we shall get P sine 30 degrees plus 4 sine 45 degrees, then plus minus this, but this is a minus, that's why we are going to take minus a Q. Then all those forces should give us a 0. Or in other words, you can say the total upward forces will be equal to downward forces. Upward we have this plus this equal to Q. So our Q is going to be equal to those forces acting upward. We have P sine, where the P is 3.27 sine 30 degrees, then plus for sine 45 degrees. So pressing the calculator, our Q is going to be 4.46 newtons. That's how we resolve these forces. Negative forces are those forces we shall consider to be taking the left side. Right will be positive. Up, we shall take it to be positive. Down, we shall take it to be negative. Then this will be positive, and this side will be negative. So that is it. So let us now go to part B. Okay, now when you look at this diagram, we have a force of 1 Newton acting upward there. It is purely vertical. We have a force of 2 Newtons. We have this force at an angle of 40 degrees. We have this force Q at an angle of 55. So even here we have this force P. Now P should be resolved, and even Q should be resolved. Now when we resolve P, we move to the right, which is positive, and up. The side which is opposite is the sine, so this is going to be P sine 40 degrees. The one which goes to the right is also positive, and it is adjacent to the angle, so it will be P cos 40 degrees. That is P. Now Q can be resolved. We move to the left, which is going to be negative, up positive. So this is going to be Q sine 55 2 sine 55 degrees. And now here we move to the left, and this left is going to be 2 cos 55 degrees. Now, to resolve these forces, we can look at all the positive forces all the forces to the right. Let us consider horizontally. Now, horizontally, all the forces moving to the right must balance the forces moving to the left. So in other words, we have P cos 40, one force to the right. Do we have any other force to the left? It is only one. This should balance that forces which moves to the left, which is 2 cos 55. So that is one equation. We don't know the value of P and the value of 2. Now, if we consider the vertical components, we have these two which are positive 2 sine 45, 2 sine 55, then plus another P, which is P sine 40 degrees. This goes up. Then there is 1 Newton. There is also a 2 Newton. This gives us 3 Newtons. No, 1 up, then 2 down. So we shall get 1 minus 2, then equal to 0, because we have added all of them. Or we can just say that all the upward forces, 2 sine 55, P sine 40, and 1 should be equal to 2, if we are to resolve in that form. So now from here, hope you can see, we have 2 equations and 2 unknowns. So I'm going to make to take this P, I think we can make 2 sine 55 the subject from here. 2 sine 55 will be equal to 2 minus 1 when we take this one the other side, so it remains 1, then minus P sine 40 degrees, then also 2 cos 55 degrees equal to P cos 40. I'm interested in solving these 2 equations. So what we can do now from here is to divide, so that we will get rid of the 2. So if we divide, we shall get sine over cos, which is tan 55 degrees, equal to 1 minus P sine 40 over P cos 40 degrees. As you can see that we are left with only P, which we can solve. So let us press our calculator. Or before pressing calculator, let us cross multiply. We make P the subject. So we shall have P times cos 40 times tan 55 equal to 1 minus P sine 40. I'm going to bring this on this side. So we shall have P into cos 40 tan 55, then plus sine 40 equal to 1. If we bring this one on the left hand side, so and we factorize P there, after we shall have this plus sine 40 degrees. So our P is going to be 1 over the whole of this which is cos 40 degrees, tan 55 plus sin 40 degrees. So pressing the calculator, P should give you 0.576. That is our P. Then to find the Q, we are going to use any of this equation. If we use equation 1, find the Q. From here, Q is going to be equal to P cos 40, which is 0.576 cos 40 degrees, divided by cos 55 degrees. So our Q will be, when you press the calculator, it should give you 0.769 as the answer.